Welcome to Explorer Classroom. My name is Kip Hotman, and I'm so glad you are joining us today, friends. Many viewers around the world are celebrating Ramadan, and we wish you all a beautiful celebration. Ramadan Mubarak. At National Geographic, we know the power of exploration, wonder, and storytelling can change the world. This Explorer Classroom YouTube show connects students around the world with our National Geographic Explorers for short lessons and time for your questions, friends. Today, our explorer is Rachael Miller. Rachael is a conservationist who focuses on protecting the ocean and keeping it clean, especially from microfibers. Microfibers are tiny pieces of fiber that get into our ocean and make it unhealthy, often coming from our clothing. They are so small that it can be hard to see, and they end up being eaten by ocean animals, which is not good for their health, our health, or the health of the ocean. Rachael and her team invented the world's first microfiber catching laundry ball and is working with her team at Rosalia Project for a Clean Ocean to create new ways to help more people protect the ocean from microfibers. Before we get into today's lesson, let's welcome our viewers who registered in advance and join us today from around the globe, friends. Our shout outs for today's episode go to, drumroll, Valley View Elementary School, Hilliard City School District, IBIME, Ecola Trilingual Vision, the Mitchell family, Griffith Thomas Elementary School, Urban Village Academy, Colegio Miraflores, the Chan family, Odea Core Knowledge Elementary School, Ocean Breeze Homeschool, and all of our homeschools out there. We are thrilled to have you all here. And with that, let's get this Explorer Classroom started. It's time to turn it over to Rachael and learn all about microfibers in the ocean and how to keep and take care. Take it away, Rachael.
Thank you, Kip. It's so exciting to be here. Okay, who loves the ocean? Raise your hands. Yes, look at all those ocean lovers. Me too. Who's got a favorite lake or river? Yes, we have lake and river lovers. Me too. I love our waterways, and my job is to protect them. I do that through expedition science, through engineering, and through teaching, just like this. Now, like Kip said, one of the problems that my team and I are working on is called microfiber pollution. And it has to do with our clothes. Everyone's wearing clothes, right? You don't see any naked people in school, I don't think. Of course not. You need clothes. Clothes protect us. They keep us warm, cool, and looking good. But what's very interesting about our clothes is that you look at them, like have a look at your shirt. It looks like it's one big thing, doesn't it? But in fact, it's made up of a lot of small fibers, and they're long, but they can break. So let's have a look at that. I'm going to show you a pair of jeans. And this is what jeans look like normally. I'm sure you would agree. Now get ready, because we are going to look at jeans through a microscope. And this is what jeans are really made of. Can you see that there are thousands of tiny little fibers? And this is good. This makes jeans soft and do what they do for us. But you can see they might be able to break off a little bit. Let's look at a fleece top. Now we're going to zoom in on the fleece. This is fleece under a microscope. And again, these are tiny, tiny little fibers that make fleece soft, but they are potentially breakable. And this breaking off of these little fibers and they can end up in the environment, it happens in 3 different ways. It can happen in a washing machine. It can happen in an electric dryer. And it can happen when we wear clothes. Like here are my friends doing a beach cleanup in Indonesia while wearing clothes. Now, my team and I have been working specifically on this problem in washing machines. Now, picture a washing machine and picture a shirt that you're just about to drop in to the washing machine. What happens next? Water pours on it, and then it starts spinning, and then it spins really fast, and then there's more water, and the clothes rub up against each other. So there's a lot going on in order to get our clothes clean, and that's good, but it can cause breaking, and it's just a little bit at a time. You can't even really see it with your naked eye. Okay, everyone's had rice before, right? So hold up your little pointy finger and pretend that you're balancing 1 grain of rice on your finger, just 1 grain of rice on the tip of your finger. Imagine it there. It's small, right? Well, now look at my magnified picture here. That little bundle of fuzz, all those colors, is a jumble of microfibers that came out of a washing machine. And can you see it's smaller than 1 grain of rice? Okay, let's look at something smaller than rice. A salt crystal. 1 individual salt crystal can still be bigger than these tiny, tiny bits of fiber that are breaking off our clothes. And because they're so small, they can escape out the drain water. They can get through wastewater treatment plants and make it to the waterways we all love so much. And here they can cause 2 types of harm to sea creatures. 1 type we'd put under the category physical dangers, and that's like getting an injury. So maybe scratching the throat of a little creature who swallows this stuff, or maybe filling their little belly up with something that doesn't give them any nutrition. And we know food needs to give us nutrition so we have energy. There's another type of danger, and that has to do with chemical danger. And that is similar to being poisoned. So that is a possibility. Now, we have to be careful about this kind of pollution or any pollution in the water, because if we eat fish, there is a chance that what the fish eats, we eat. Now, microfiber has not just been found in fish. Microfiber has also been found in tap water. It's been found in bottled water, honey, salt, and beer, which you don't need to worry about right now. But this is one of those problems that, have you ever had a problem that just speaks to you a little bit? This problem screamed at us. And so we knew we had to work on it. And we made 3 goals. Those 3 goals were to first, learn everything we could about the problem and discover new knowledge, because it was a relatively new problem. And we do that through expedition science. We wanted to develop a solution, and I can't wait to introduce you to ours. And our goal was also to inspire innovation or new ideas and new solutions, and to raise awareness about the problem to people of all ages. So let's start with the expedition science and introduce you to our sailing research vessel. This is the boat from which we do our work. And we set out on this boat to answer the question, what does microfiber look like in the wild? And the place we did that was in the Hudson River. This is New York State in the northeast of the US. And if you start at the top of the screen, those are the Adirondack Mountains where the Hudson starts. And each of these blue dots is one of our sample sites. And we sampled from the mountains all the way past New York City to the sea, where the Hudson River meets the Atlantic Ocean. And we sampled the surface of the water by throwing out a middle bucket and taking the sample. We used a little machine to sample the air. That's me pulling the machine down. It was up the mast. And that's a Statue of Liberty behind me. That was a really fun day. And here's my fellow scientist, Brooke. She's taking a soil sample so we could see if there are microfibers sitting in the forest and on the sides, on the beaches as well. And here's what we found. We found microfiber in the wild. You can see this kind of looks like it might have come from some clothing, perhaps somebody's red shirt. And what we're doing with those results is we're using them to make strong solutions as we can, and we're publishing them to share that science with people all over the world. Now I'm going to introduce you to the Cora ball. So that second goal of ours was a solution, and this is the Cora ball. The Cora ball is a microfiber catcher that you put in your washing machine. Any washing machine, you just toss it in or drop it in, and it works with your clothes, not against them. But remember, there's tiny, tiny microscopic pieces breaking off of our clothes while this is happening. And those tiny little pieces are floating around in the water. And so the Cora ball can catch them. And here's what it looks like. It tangles them into a fuzz ball. So there's a fuzz ball right there. We're pulling it out. Now it looks kind of like hair, doesn't it? Just with your naked eye. So let's get the digital microscope and see that it's so many pieces of tiny little microfibers. And that's pretty incredible because all of that happened in this tiny little, what looks like a gray fuzzball without that microscope. Now I have to say, all of our attempts at solving this problem did not work. The first tries didn't really work. It didn't catch the fiber that we wanted to. Now, this is a standard thing that happens when you're trying to invent something new, and often in science, is you ask a question that may not have an answer yet. And so it sometimes takes steps of trying something, it doesn't work, you learn, you try something else and see if that works. And we got to a point where we had to just stop and think, what are we trying to do? And we realized we were trying to catch small things, the microfibers, from moving water. And we thought, who does that? Does anybody do that? Coral does that. Coral is stuck to a rock and it catches small things from moving water, plankton, as it floats by. This process has a big word called biomimicry, but what that means is being inspired by nature to solve problems. And so thanks to the ocean itself, we were able to make something that helps catch microfiber in the wash. And right now we have shops all over the world, and even better, we know that there are people using Cora balls in over 60 countries to help stop microfiber pollution. But this is not just something that grown-ups can do. You can be part of the solution too. One way is to only put clothes that are really dirty in the hamper. So don't wash everything just because you wore it. If it's dirty, wash it. We need clean clothes. But if you wore it for like 10 minutes and didn't spill anything on it, it doesn't need to be washed. Another way you can be part of it is to get excited about the ocean, learning about the ocean, discovering new things about the ocean, and being excited about science and engineering and topics that will help make even better solutions than the ones we have. Here are some friends helping me with taking a sample off the boat. And then beyond just getting excited about learning science, you can do something that National Geographic calls science telling. And this is one of my favorite things. And it's explaining what you've learned and sharing results. And you can do that so many fun ways, videos and pictures and art. So I'm going to end here by saying thank you for what you're doing to protect our ocean, lakes, and rivers, and to share something I believe. And that is the concept that lots of littles make a big. And what that means is lots of tiny little pieces of microfiber can add up to a big problem for our public waterways. But lots of little efforts together can make big impact. You are lots of littles who can make a big impact. And I am so excited to take your questions.
And we have one last question, which serves as kind of a call to action for our audience as well. And you just shared some ways to become involved and be thoughtful about clothing and microfibers. Are there any other recommendations on how we could take on your mission to help reduce and stop microfiber pollution?
Thank you for that. I love that. So we'll do quick review for the big ones. All right, all you students out there, your best plan of action is to wash the clothes that are dirty, but don't wash clothes that are clean. And that way you students will help reduce microfiber pollution. In the big picture, this is about remembering that our homes are connected to our natural world and that anything that we put down the drains can end up back into our public waterways. So an overall thought about that and employing some of these techniques, cold water, full loads, will make a very big difference. And I do encourage people to learn more on Rosalia Project or Coraball and to know that every effort adds up. Lots of littles make a big.
I love that. Lots of littles do make a big. And I've learned so much, and I'm sure our audience can agree that we all have, and how we can help you and your mission, Rachel. Thank you so much. And thank you, all the students and teachers out there. I hope you join many more of our events, including an upcoming show about aquatic life in the Amazon River Basin with explorers João Campos Silva and Andressa Scavin. You can register your student group for a shout out during the event and a chance to be on screen at, here we go, natgeoed.org/Explorer Classroom. My friends, don't forget that April is Citizen Science Month. We hope all of our viewers have a chance to learn outside and discover something new, maybe with the apps iNaturalist and Seek. Other than that, friends, have a great day, everyone. Stay curious, keep exploring,